Hi, Mr. Troja. This is my reassessment for CFPM.1 and 2. So I'm going to start with CFPM.1, which is solving for the acceleration of an object moving in a circular direction. So my lovely little sketch over here is a roller coaster loop-de-loop, and this is a roller coaster car. I am a fantastic artist. I gave myself some values just modeling after ones in the packet because I solved most of the problems, almost all the problems actually in the packet and everything, and so I just wanted to kind of model it after that because that seemed the most apt way to prove that I understand. So I changed the values and everything. So I gave myself a radius of 490 meters and a velocity of 70 meters per second. So I'm going to calculate the acceleration really quickly. I'm going to take my velocity, which is 70, and square it, dividing it by my radius, which is 490. I'm going to calculate that really quickly. My acceleration happens to be a nice even 10 meters per second squared. So, awesome. That's the first part of it. Cool, that's pretty straightforward. I hope that is clear enough. So the second part is just explaining that I understand how the forces are acting on the different types of on the circular motion, I guess I should say. So this lovely drawing over here, I'm going to use this as an example. I'm going to draw some force diagrams really quickly. So this is the car at, I guess there are multiple stages throughout the ride, I guess. So the car begins and it has gravity forcing down on it at stage 1, say, and then it also has a normal force balancing it out, right? Because otherwise it would fly off the track. And it also has a applied force from the motion previously. So that's pretty straightforward, right? It's pretty simple. I guess this should actually be tilted a little bit just because it's on track. So that's tilted. Anyway, the point is, at stage 2, when it's up closer to the top of the roller coaster, you have forces pushing down on it only because it's there for only a moment. So luckily it doesn't. That's why it doesn't fall off the track. So you get a force of gravity. But it's not very strong because of the high normal force. So it doesn't need it, and the force of tension is incredibly strong at that point. Yeah, and then say like stage 3. Yeah, so stage 3, it's coming back and around, and so the forces are lessening around it a little bit. At least the tension forces are, because it's no longer being held in place at the precarious top. So you still have your force of gravity. That's always going to be there, but you also have a force of tension, but it's pushing in toward the center, because the force of tension is always pushing towards the center of the circle, because that's how it keeps it within the circular motion. I really hope that covers it. That is my reassessment for CFPM 1 and 2. Thank you very much. I will see you tomorrow.